Sir, Funny sir raised the hand. Sridhar sir. And one of the participant also. You Anjaneyulu.
Fanindra ఎందుకు అంటే అన్మ్యూట్ చేయమనే?
ఏమో సార్ హ్యాండ్ రైజ్ చేశారు ఒకసారి.
Okay, once you check the chat box.
Okay sir, I'll message.
Is there any message? Sridhar sir, YouTube link ఇచ్చేయండి ఎందుకంటే ఇక్కడ పార్టిసిపెంట్స్ ఫిల్ అయిపోయారు.
Right sir, I'm doing that. Sir, YouTube link is posted in the chat box, sir.
Okay. శ్రీధర్ సార్.
సార్
ఫనీని ఒకసారి అన్మ్యూట్ చేయండి, ఫణీంద్ర సార్ని.
యా సార్.
శ్రీలేఖ.
సార్.
ఓకే, స్టార్ట్ ద సెషన్.
ఓకే సార్. Shall I start, sir?
Ma'am, you can start now.
Okay.
Okay, sir. Good afternoon, ladies and gentlemen. With a great joy and immense exultation, I feel privileged to extend my warm welcome to all presented here for the national level online webinar series on research challenges in power electronics and power systems commenced from 5th to 7th August 2020. This webinar involves the pride and is emerged under chairman of Balaji Group of Institutions, Dr. A. Rajendra Prasad Reddy, respected Secretary, Dr. G. Rajeshwar Reddy, and our beloved principal, Dr. V.S. Hariharan. It has become a regular aspect and a part of Balaji Institute of Technology and Science as an academical program to organize the several webinars and faculty development programs through online platform due to COVID-19 pandemic. Our institute is located on Nasampet Warangal Highway and is affiliated to JNTU Hyderabad, accredited by NBA and NAC. We strive towards the students' welfare, academic growth, and overall personality development by providing campus recruitment training with 100% placements for all the streams. Till now, our students were placed in prestigious private sectors like Cognizant Solutions, Capgemini, etc., and also in various public sectors. I am honored to announce that this webinar is organized by Department of Electrical and Electronics Engineering. The convener of this program is Mr. S. Mallikarjun Reddy, Head of the Department EEE, and the coordinator is Dr. R. Shervanan, Assistant Professor, Department of EEE. Firstly, I request the webinar coordinator, Dr. R. Shervanan, to the address participants.
Thank you, madam. Good evening to everyone. I welcome to Chairman sir, Secretary sir, Principal sir, today resource person Dr. K. Bhaskaran sir, HOD sir, participants and my dear faculties. I thank Chairman sir, Secretary sir Principal Sir, HOD Sir for given opportunity to conduct 3 days webinar on research challenges in power electronics and the power system from 5th to 7th August 2020. I thank resource persons Dr. K. Bhaskaran Sir, Dr. P.V. Ramarao Sir, and Dr. K. Sabastirani Ma'am for accepted invitation to deliver speech on 3 days webinar. Today, Dr. K. Bhaskaran Sir deliver on topic research challenges in on 6th August. Dr. P.V. Ramarao Sir deliver on topic research challenges in electric vehicles. On 7th August, Dr. K. Sabastirani Ma'am deliver on topic design and cost estimation of solar PV system for domestic appliances. Totally 700 plus participants registered from various institutions and industries from many states in India and abroad. I request all participants to attend this webinar for 3 days. Thank you once again. Over to Sri Lanka, madam. Thank you, ma'am.
Thank you, sir. Next, we look forward for the presence of our HOD of EEE Department and convener of this webinar, Mr. S. Mallikarjun Reddy Garu, to share his few words.
Okay, thank you, Sri Lanka. Respected today's speaker, Professor K. Bhaskaran, Chairman Sir, Principal Sir, faculty, and dear participants. A very good afternoon and warm welcome to all of you for this online webinar series. At the outset, I take this opportunity to thank our principal and chairman for immediately accepting my proposal to conduct this webinar series. My sincere thanks to all the resource persons, namely Dr. K. Bhaskaran, Dr. P.V.V. Ramarao, and Dr. K. Sabastirani Madam for accepting our request. This webinar series is very useful to improve your knowledge and it helps in research activities. Thank you. Okay, over to Sri Lanka, madam.
Thank you, sir. Please accept our sincere appreciation for the outstanding support to organize this webinar. And now I am profusely elated to take an opportunity to introduce our honorable speaker of this day, Dr. K. Bhaskaran, presenting today's topic, Research Challenges in Smart Grid. Dr. K. Bhaskaran sir, working as an assistant professor, professor and HOD of EEE Department in AC Government College of Engineering and Technology, Tamil Nadu. Presently, he is a placement officer in AC Government College of Engineering and Technology, Tamil Nadu. He has more than 31 years of teaching experience and published more than 230 papers in various reputed journals and conferences. He is the research supervisor of Anna University, Chennai. He is presently providing the guidance to 7 members research scholars, and 26 research scholars have already completed their doctoral degree under his esteemed guidance. He completed PhD in Information and Communication Engineering from Anna University, Chennai in 2006. And he completed his Master of Electronics in Computer Science and Engineering from Bharatiyar University, Coimbatore in 2002. And Sir completed his Bachelor of Engineering in EEE from Annamalai University in the year of 1989. His area of research is wireless sensor networks, smart grid, and alternate energy resources. He is the reviewer of so many reputed journals, and also he is the senior member of IEEE and ISTE. He served as zonal officer for Coimbatore Zone, Anna University for about 7 years. Now, I request our beloved principal, Dr. V.S. Hariharan Garu, to speak few words about today's webinar.
Very good afternoon to one and all. Respected Professor K. Bhaskaran, Professor of EEE Department, AC Government College of Engineering Technology, Karaikudi, Tamil Nadu, for accepting our invitation and to be part of this webinar series. And the convener of this webinar series and the head of the department, Mr. Mallikarjun Reddy, and coordinators, Dr. R. Saravanan and Mr. S. Sridhar, other faculty members of the department, and my dear participants. So it's very happy to note that the Department of EEE is organized. They have organized many webinars for the students till yesterday, and right from today they are organizing the webinar series, especially for the faculty members. So in this connection, I appreciate the department, head of the HOD and other faculty members, and the support given by the management for organizing this webinar, followed by a successful conduction of the faculty development program in the last month. And I thank all the resource persons for these 3 days for accepting our invitation and ready to deliver the research topic. So in different areas. So I thank all the participants for registering once again. So, okay. And as the overwhelming response is seen for this webinar, also more than 700 participants are present in both YouTube as well as in the Zoom platforms. So I thank once again today's speaker, Professor K. Bhaskaran, for going to present today's topic on research challenges in power electronics and power systems. Thank you. Thank you once again.
Thank you, sir, for your wishes. On behalf of the management and Department of EEE, I thank Dr. K. Bhaskaran, sir, for providing his gracious presence to join us today to enhance our knowledge. I request Dr. K. Bhaskaran, sir, to start the session. Over to you, sir.
Thank you, Sri Lekha. Thank you, Balaji Institute of Engineering, Warangal. Thanks to principal and management, HOD and faculty members. I feel much happy to meet you through this webinar on research challenges in smart grid. Now, shall I share the screen?
Yes, sir.
Yes, sir.
Thank you. Able to see the screen now?
Yes, sir.
Yes, good. Yes.
Good evening to all. I feel much happy to do the presentation on research challenges in smart grid. We'll say about a smart grid. Smart grid starts with the power grid. We know very well about power grid, power systems. The power system means it starts from generating station, transmission, distribution, and consumer usage. In the vast area of power generation to consumer point of view, we have a huge equipments connected with the power systems. Different types of power generating stations available, different types of consumers are available in the total power system, power grid. The generating station generates electrical energy. We know very well about the energy can be converted into one form into another, neither created nor destroyed. It can be transferred from one form of energy into another form of energy. So we are converting energy from different form with the help of the various power station like thermal power station, nuclear power station, hydel power station. These are all the power stations. Majorly, we are generating power. With the help of the power, we are transferring power to the other end. Why we are having the power station at one end and the not close with the users, consumers. The reason behind it is based on the availability of the fuel, based on the availability of the disposal of the wastes, and it should not give any disturbances or pollution to the public. That's why the power generating stations are far away from our place. The reason behind the hydroelectric power station is just because of the availability of potential energy of water. We are locating the hydroelectric power station in the hill areas. In the new thermal power station, definitely we need a coal. The coal is the main fuel, so we are using the coal. If it is a nearby coal mine, it will be easy to operate the thermal power station. So we are selecting the thermal power station in the nearby coal mine. And in the nuclear power station, if you consider, the fuel is not that much base, but the problem is we need to dispose and the pollution problem. To avoid such problems, it is designed nearby seashore or far away from the thickly populated areas. So we need to transfer the generated power from one end to another end. That is the main disadvantage of generating power. And meeting out the requirement of load. So based on the availability of fuel and waste disposal, we are designing power generating station at the other end. Power generation one end, usage in the another end. So we are not in a position to do proper monitoring. We need to do the proper monitoring. That is more important. If you are monitoring, we may avoid wastage of power theft, etc. In the existing power grid, we are not in a position to do all such activities of wastage of power and power theft. We don't have a proper monitoring system in this. The another way, if you consider, we are having the enough amount of power generation based on the requirement or load demand. We are having the power generating station. So the power generating station produces power and transfer the power to the load side. We are generating some amount of power. If the power is greater than the requirement of power, there is a more than the load. So what will happen is, if you are generating more amount of energy, we can store some of the energy in some places. Otherwise, if you are generating power equally what the requirement, whatever the power we are generating, we can utilize the power. Like a salary, what we are getting salary is, we are earning more amount of salary. That time we can save some amount of power, amount in the bank or through some other way. Similarly, we can save electricity. One of the main disadvantages in the electricity is we are not in a position to store huge amount of electricity. That is the main disadvantage in the electricity. Now, actually, I given the power generation is more than the requirement. The another one is the power generation equal to the load. Definitely, these two are not in a current situation. Definitely, we required the demand is more. Power generation is minimum. The basic reason is why we are having the power, not planning for the better power generation. The load is not uniform. The load may vary time to time. If your load is in the evening hours, it will be more. The loading in the night hours after 10 o'clock to morning 6 o'clock, the load is very minimum. So if you want to start the generation, definitely that required the hydroelectric power station or nuclear power station or thermal power station, that required some warm up time to generate power. So immediately we cannot switch on, switch off the power generation. So we are not able to supply power during peak hours. That is the main first problem with the existing power grid. In the power grid, we are not in a position to do all such monitoring system and controlling system just because of the variable load and variable demand. So we are having this such a problem. I have given the very basic idea about the power system and the existing power grid. Now we'll see about what is a smart grid, how the smart grid going to solve the problem. And we'll see about the research issues in smart grid. Am I audible to you all? I'm talking. Is it okay?
Yes, sir. Yes, sir.
Is it
Yes, sir.
okay?
Yes, sir.
Okay. Shall I continue? Okay, please. Now, what is the vision of a smart grid? The vision of smart grid is transform power sector into secure, adaptive, sustainable, and digitally enabled ecosystem that provide reliable and quality energy for all with the active participation of stakeholders. So we are going to have a mainly secure, adaptive, sustainable, and able to control. That is the main thing, main aim of our vision of the smart grid. Then we'll see about what is a smart grid. Smart grid does not have any proper definition so far. Each and everyone have their own definitions. Smart grid is an electric grid with automation, communication, and IT system that can monitor power flows from power generation, point of generation to point of consumption, that is in the application level, and control the power flow or curtail the load to match generation real time or near real time. The reason behind this, whenever we want more amount of power, it is capable of supplying more amount of power. Whenever we need to reduce the power, less amount of power is required, we can reduce the generation. This is possible with the help of the smart grid. So we have seen about what is a smart grid, how to achieve a smart grid. How to achieve a smart grid? Actually, we are having existing power grid. How can we completely throw the existing power grid and we can install the new smart grid? It is not an easy one. Smart grid can be achieved by implementing efficient transmission distribution systems, system operations, consumer integration, and renewable integration. Smart grid solution helps to monitor, measure, and control power flows in a real time that can contribute to identification of losses, and thereby appropriate technical and managerial actions can be taken to arrest the losses. Main thing is we need to minimize or reduce the losses. That is the main thing. Here, the important thing is our special features of smart grid is a real-time monitoring. That is the main thing in the smart grid. What do you mean by real-time monitoring? What is the problem with the real-time monitoring? I want to share a small story related to the real-time monitoring. One doctor going by a car, and he wants to travel to his nursing home. That time, what he is doing is, while traveling car, he get a problem with the car, and he simply the car has stopped. Then he searched for a mechanic shop. The mechanic shop is nearby, is available. Simply he called the mechanic and asked the mechanic to rectify the problem. And the mechanic came and he searched for something, and he has done many things, and then he engine, and he removed some blocks, and he can complete the work, and the engine has started and given it to doctor. The doctor said thank you, and he started moving. That time the doctor gave the money, asked the person how much. He said that 250 rupees. So he paid the money and he started moving. That time the boy is asking, sir, 1 minute. The doctor said yes. The boy is asking, sir, in the car, the engine is the heart of the heart for a car. I'm removing block from the car. You are also removing block from the human. Now I have removed the block and I got just 250 rupees, 250 rupees. But if you are removing the block, simply you are collecting lakhs and lakhs of rupees. Why you are collecting that much amount? The doctor got smiled and informed him, goodbye. It's a very good question. What you have done, when you have entered into your workshop, the car has got a problem and it is not working, functioning, and you have done something and you started the engine and give it to me. But you are admitting in the hospital with the running engine, that is, a heart is running. If the heart gets stopped, we'll do nothing. I'm working in the running engine, running heart. That heart should not get stopped. Without stopping the engine, will you able to remove the block in your car? The boy got surprised. I can't do such a work. Only switched off the engine and then we are doing all such operations. The difference between the working with the live system and working with the offline system. The live system is more important. That is we are doing in the smart grid. In the smart grid, we are doing all such operation without disturbing the power supply to the consumer, without stopping the power generation from the generator. So important things in the smart grid is we are working with a real-time monitoring, real-time working, real-time operation is doing in the smart grid. So another feature is automated outage management. Automated outage management and faster restoration. Whatever the problem we are getting, it is getting recovered very fast. Dynamic pricing mechanism. Based on the time, we can have a pricing mechanism. I'll explain the dynamic pricing mechanism in later slides. Then incentive consumers to alter usage during different times of day based on the pricing signals. Better energy management. In-house displays. In the houses, we can get a display, how much amount of energy we are utilizing, what are all the equipments, now it is in on condition, what are the equipments unnecessarily you are using it. So everything will get, that is in-house displays available. Then web portal and mobile applications. If you want to switch on your AC, you are going in the hot summer days, you are nearing to your house, automatically your mobile phone detect your area. If you entered into the area, the mobile phone started with the help of the IoT. IoT also plays a major role in the smart grid. The IoT, with the help of the IoT, your mobile phone get detected and give information to your AC. The AC should be switched on. When you entered into a house and you are switching on the AC, they take another 5 to 10 minutes to get cooling. Instead of that, automatically the IoT and the smart grid does the functions of operating your AC. And if you've forgotten something to switch off your motor in your houses and you move to your office or somewhere else, with the help of the mobile app, you can switch off your motor pump. It is pumping water to the water tank. So everything possible with the help of the smart grid. Then track and manage energy usage. The energy usage can be managed and we can track opportunities to reduce and conserve electricity. This is possible. Smart grid will also facilitate generation, especially the rooftop solar generation. So far, I have given the power system about 3 conventional energy sources like hydel, thermal, and a nuclear power station. In addition to that, we are having power plant. There is a solar plant in your house rooftop. It can be used in the power grid. The smart grid can accommodate your power generation, and it can take power from your house, and whenever you require power, you can take power from the electricity board. So this is possible with the help of the smart grid. So this is possible with the help of the net metering, and other things are available in the things. And some of the benefits of smart grid is it reduces the transmission and distribution losses. Definitely we can have a continuous monitoring. So it is getting reduces the transmission and distribution losses. One of the incident I want to say, one example, you'll get a clear-cut idea. In the power, in the water plant, our water used to supply from the corporation to individual houses. From the water purification plant to the local place, they are transferring water, and from there they are supplying power to the individual houses. If the system is normally going with the human monitoring, some places, some people can tap water in the underground from the underground pipe, and they can utilize the water. No one knows that who is utilizing the power. Sometimes some houses, they use some motor to take more amount of water. We don't know where or who is doing such a mole operation. Similarly, the water supply board doesn't have any monitoring system, proper monitoring system. Now the water supply board also, they have started doing PLC based monitoring system. In a PLC based monitoring system, each and every periodical places they can have their own sensor. The sensor are connected with the centralized system, and they can have a calculation of how much amount of water is dispatched from the delivery point, and how much amount of water is transferred to your local waterhead tank, and from the water tank to your house, how much amount of water is transferred. So we have a clear-cut idea, clear-cut information about how, any wastage of water in any point. So each and every periodical places, we have a sensor, PLC-based sensor. The sensor monitoring and gives information. Similarly, I gave example to understand the water problem. Similarly, in the power also, we can have a sensor in each and every places. If you have any theft in between, we can easily able to get idea about the thefting of things in the power. So we can definitely we can reduce the transmission and distribution losses with the help of the smart grid. The peak load management improves. The peak load management can be managed. I will explain in another slide how we are managing peak load with the help of the smart grid. In the smart grid, we are having smart meter. With the help of that, we can reduce the or we can manage the peak load, and with the help of that, we can improve the quality of service and reliability. Reduction in power purchase cost of the power is getting reduced because of the smart grid. Better asset management is possible. Increased grid visibility and self-healing grid. Self-healing grid is another important point in the smart grid. I'll explain later about self-healing grid. Renewable integration and accessibility to electricity. Already told you that the power generation will have the three conventional power generation. In addition to that, we are having our own power generation. We will have the rooftop solar panel and windmill. So from that also can be connected with the grid with the help of the smart grid. Increased options such as a time of usage tariff, net metering is possible. Satisfy customers and financially sound utilities, etc. is advantages of the smart grid. Now you can see one slide here. I think able to see the traditional power grid versus a smart grid. Here we have a power grid. With the help of this, the power plant we are having here. The power is generated here, and the transmission lines carry electricity for a long distances. Then neighborhood transformers step down the voltage, and the distribution station, from the distribution station then transfer to the local tower. The local tower, they are reducing the power into minimum level, then they are supplying to the houses or consumer point. In the smart grid, you can see that this is the power plant. This is the one power plant. This is another power plant. This is the another offices with its own generator. Whenever we will get power from the power grid, it can consume. Whenever power is not available, the power can be generated with a diesel generator, or other places. Even we have a we have a windmill. The windmill also generating power, and it transfers the power to the grid. Here we are using control center. The control center is connected with all such things: the power station, houses, residential areas, solar panel, windmill, energy storage like a battery, and the vehicle producing its own power. This is another vehicle producing power with the help of a hydrogen car. So everything is getting connected, and it will manage with the help of the smart grid. So we can able to see this is a smart grid is connected with all such things. So difference between the smart power grid and smart grid. This is the existing one. This is the new one. The new one we are having. The existing one we are having the power line alone, and here we are having a power line as well as communication line. The power line as well as communication line. So that give a major role about the smart grid. Again, another diagram can explain about the generation of nuclear energy, then local generator, renewable energy. You may get a clear-cut idea about the power generation, the cross-border interconnection that is going here. So this is the red line source about a power network. It is transferred to the intelligent substation, and a remote control wide area monitoring system is available here. So from this, we have grid automation, smart switch. Then it is transferred to the houses, transferred to the some of the load centers. Everything may be controlled with the help of the remote control wide area monitoring system. So this is the complete control of smart power system. Okay. So this is the another one is the daughter line. So support a telecommunication line. The telecommunication line is connected with all such things. So we are able to see all such connections are we can have a two-way communication. One of the important concept in the smart grid is we have a two-way communication. In the previous grid, we are having power is generated and we are transferring power to the individual houses. So the individual houses can get power. If you get any problem in your houses, simply you want to go to the nearby EB office, you want to inform to the EB person, or nowadays we can ring up and we can call the EB office and say that we have some problem in your houses. Then the EB person used to come to your house and he'll rectify the problem. But nowadays, with the help of the smart grid, it is not required. Simply from the control center, they can able to monitor your house. If your house is not getting electricity, they will get some indication. So with the help of the indication, they try to rectify from their place, or even self-healing is there. Sometimes it will automatically rectify the problems. Okay, so this is the overall idea. The diagram gives the overall idea about a smart grid. So this is about a similar things about a smart grid. So various things about IEEE standard. So definition from the National Institute of Standard and Technology. I already told you that the smart grid doesn't have any proper definition. The researchers can given their own definitions. The modernized grid that enables bidirectional flow of energy and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. So it is having a two-way power communication, power transmission, as well as a two-way communication, and able to control. This is the definition that is given by NIST. And IEEE has given another definition. Smart grid is a large system of systems where each functional domains consist of three layers. One is the power and energy layer, another is the communication layer, and third is the IT and computer layer. The IT and computer layer as well as the communication layer is new one with the existing power grid, and that create the existing power grid as a smart grid. The smart grid is nothing but it is having an intelligent system. The intelligent system can make the existing power system as a smart grid. So the difference between the conventional grid and the smart grid we are having, if you see this, we'll get a sum of the research idea why we are having the problem in the smart grid, how to solve the problem, what are the research areas available in the smart grid. So we can classify, characteristics of architecture, consumer participation, generation, storage options, power quality, new product and services, asset optimization, self-healing. So here, as per the architecture, previously we don't have any hierarchical, we have a hierarchical or vertical architecture from the top to bottom, from the power generating station, then transmission station, then receiving station, then the substation. From there we have customers. But in the smart grid, we have unbundled and distributed structure. We don't have any hierarchy in this. In the consumer participation is a non-participative and uninformed. If even previously, 10 years back, if you get any power problem, no one knows when the power goes, when the power will come. But nowadays, you will get a periodical information. If you have any operation or services they are going to do, they are giving information to us through mobile, or they are giving information that the power will be cut from this time to this time. So the informed and participative customers are available in the smart grid. Then the generation and storage option in the central generator domains, no storage framework in the existing smart grid. And in the present situation, we have a distribution energy resources with the plug and play features. We have many resources. Any resources can join with the power grid and they can produce their own power. And if they want, they can take power from the grid. So this is possible, the generation storage option in case of a smart grid. And the quality of power is in the conventional power grid, the power quality is poor. And in the smart grid, the power quality is the first priority. There should be power quality with the proper supply of voltage, proper. It should maintain the voltage level, and it should not be any break, or it should not have any breakdown. Anything, nothing will happen in the smart grid. And a new product and services, very limited, poor in customer focuses. Here, better market and services for customers in case of a smart grid. Asset management is a poor, little, and data integration. Here, the data-driven predictive asset management. We can predict what are all the problems, we will get it with the help of the sensors. So we have a data-driven, and asset management is possible in the smart grid. The next one is a self-healing. Is one of the important concept is self-healing. In the previous case, we don't have any self-healing. I already told you that if you have any problem in the houses or even in the street, overhead line get fallen, no one knows. Simply some people or animals can touch the wire and they will get a problem of shocking and other things. But in case nowadays, if you have a self-healing, automatic, predictive, and fault address. So self-healing in the sense, if you get any problem, automatically it will recover on its own. The reason behind it is each and every place we have a sensor. Sensor gives information periodically to the control center that this wire is getting damaged, the wire is getting problem, or the machine is getting problem. Even in your houses, we are having a fan. Fan is running continuously. If you have any problem with the fan, sometimes the fan gets sound just because of the bearing. If the bearing is not good, if you are not applying oil or grease to the fan, what will happen is the fan get damaged. If you get a more heating, the coil get damaged. So simply the total fan is getting damaged. Instead of that, if you have a sensor placed in the fan give information about your about you. The fan is abnormal heat. Fan is getting abnormal heat. It should be done service. Then we can do the apply oil or some greases, or we can call a technician to do such things, and it will get recovered. The fan is not getting damaged. Similarly, if you have a light also getting having some sensors. If you have a washing machine also have some sensors. So it will give all such things, gives the information, and if you have any problems, it will try to recover on its own. There is a self-healing, automatic, predictive fault addresses. If you have if you get any fault, it will inform you prior to the fault. You are going to get such a problem. So this is the more reliable. It's a self-healing one. The another thing is cyber attack. Cyber attack is possible. People used to say that if you want to attack some country or a place, first the attack will be the power station. If they are attacking a power station and make the city as a dark, simply they can capture the total country or city. So here the attacking a power generating station is not an easy one. But in case of a smart grid, easily we can attack. There is another disadvantage in case of a smart grid, as well as we have a various mechanism to get information from the different places. So we may able to safeguard our power station also. You know about power station, with the help of the password, we are able to control everything. If one person knows a single password, easily they can operate the total power station with the help of the particular system or particular software. So this is easily cyber attacks easily more attacks possible in case of a smart grid. And another one is a disaster management. If you have any disaster management or some problem occurs some time, the recovery will get slower, and it will take weeks together or months together to get a recover. But in case of smart grid, quick and proactive responses to disaster. And event analysis, it's a slow and tedious event process. But in case of a smart grid and analytics with the forecast, every time we are predicting, before getting a problem, we are having some idea. So if you have an idea, we may able to manage easily. Okay, before getting rain, if you have an umbrella, you feel that it's a cloudy. If you have umbrella with you, definitely you feel that we may not get into problem. If you don't have any prediction, simply you're going, you'll get into rain. Simply like that, the prediction is possible in case of a smart grid, and before getting problem, we can solve the problem, or we come out of the problem. The communication, previously it is a one-way communication from the generating station to the consumer. But in the smart grid, it is integrated two-way communication. So from the generating station to consumer point, as well as the consumer point to generating station, easily possible. So two-way communication in case of a smart grid. And a predictive, previously in conventional grid, we don't have non-predict and a process and apps. But in case of a smart grid, it is predictive and a process and applications. Now in the intelligent system, previously we have a limited intelligence. Now we are using all such intelligent devices to integrate and process the critical informations. So we are having more intelligent devices in the smart grid, and efficiency is poor in case of a previous one. Main aim is, in the aim of the smart grid is efficiency. Efficiency should be maximum. For that we are working. So these are all the various comparison and advantages and some of the disadvantages we have in the smart grid also. The smart grid enablers, who are all the enablers of smart grid is, it is a clean and flexible generation. It share the renewable energy source to increase the clean and flexible generation. We can, if you are having more amount of solar panel and windmill, definitely we can increase the power generation with the help of the solar and the wind. It is doesn't have any carbon problem. You don't have any pollution problem like a nuclear power station. Simply we can avoid all such problems. Sorry. In the transmission side, if you take it's a flexible transmission, we can have flexible AC transmission as well as a high voltage DC transmission. We are having our own DC microgrid also. DC microgrid also available. So energy storage system is possible in case of smart grid. We can have a capacitor, battery bank to store more amount of energy to meet out the peak load. And a system-wide secure communication is possible in case of a smart grid. And automation with the help of SCADA, EMS, synchro, phaser, and other automation devices, we can have automation. And we have an active distribution network, sensors in the sense of smart meters and PMU. I want to share some of the points related to the smart meters. Smart meter is one of the important component in the smart grid. Previously in our houses, we used to have electrodynamic meter. The meter used to rotate on its own, which is having a magnet. The magnet can, if you get some problem with the magnet may move from one place into another place. What will happen is the rotation of the disk may vary. Some people purposely, they want to do some magnet, powerful magnet, they can put near to the meter. What will happen is the disk start rotating, or sometimes the disk started rotating fast. So if something happened, they can manipulate the power consumption of the houses. And some people, so what they used to do is they will do reverse the polarity of the connection. Previously, that time what will happen is the meter started rotating in the reverse side. So the EB, whatever the power consumed for 15 days, then they reverse the connection. What will happen is at the end of the month, it started rotating in the reverse and the meter going to the reverse. So the meter may show minimum amount of energy consumption or it will be zero. So these are the problem or theft can possible in case of a previous electrodynamic meter. But later stage, they are having some lock. If it started rotating in the reverse side, that will get a lock. And even if you see the previous meters, each and every houses, they have a small seal, metal seal in the existing meters. So if you open the meter and if you reverse the connection, you will get a penalty. So that are all the things they have done to avoid for the theft and other problems. But nowadays we have a smart meters. Smart meter is one of the electronic meter. It is having a communication equipment and intelligent meter. In the smart meter, each and every device is connected in your house is connected with the smart meter. It is having its own sensor. If you have a washing machine, fridge or geyser or any electronic equipment, electrical and electronic equipment available in houses can be connected with your smart meter. It can monitor each and every devices available in your houses, and it will give the report to the control center from the smart meter, it can periodically, every 5 minutes or half an hour, or according to our settings, it can transfer the power consumption, how much amount of power consumed by the individuals can be transferred to the centralized places. So smart meter will play a major role in the smart grid. Smart meter can avoid all such problems of thefting, and the smart grid can avoid taking reading each and every month or by month. And the people from the TNEB electricity board, they can take the meter reading. The smart meters replaces the unnecessary human visits in your houses. So every 5 minutes or periodically, it can give information to the control center for the power consumed or what are all the things you are doing. And some of the industry, they can go for lagging leading power or induction load. So what will happen is that will take more power from the grid. That time they'll get a penalty. The smart meter can avoid all such things. Then we can have a wide area monitoring and control. Then we have a regulatory framework, everything the enablers of smart grid. And some of the few concepts in the smart grid is prosumers. We used to call consumer producer, but in the smart grid, we may be a consumer as well as a producer. If you have a power plant, there is a solar plant in your house's rooftop, I am a prosumer. I can generate power during daytime from morning 10 o'clock to evening 4 o'clock or 5 o'clock with a good sunlight. The power can be produced from the solar plant. And the solar plant power, definitely in the daytime, we are utilizing very minimum amount of power. During night hours, we are utilizing more amount of power. But definitely night hours, we don't get power from the solar panel. So what will happen is we are connecting our power, whatever the power we are producing from the solar plant can be transferred to electricity board authority for the with the help of the net metering. The net metering, they can have a calculation that how much amount of energy we have utilized from the or consumed from the electricity board and how much of amount of energy we have generated and transferred to the electricity board. They can see the difference. They can give the bill for excess amount of energy what we have used from the electricity board. So far, they don't have any provision to give power, excess amount of power we are transferred to the TNEB. They are not producing, they are not giving any power, any amount to the individuals. Okay. So another one is a virtual power plant is another concept. We can connect all such individual plant and it will act as a virtual plant, and whenever we need a things, it can supply power to the required places. And another one is a virtual synchronization generator and advanced distribution management system. These are all the few concepts in the smart grid. The distributed energy resources are photovoltaic cells. India aims at 100 gigawatts by 2022, and solar, thermal, small wind systems up to 50 kilowatts, large wind systems up to 1 to 2 megawatts, biomass, etc. are distributed energy resources. We have started utilizing or generating power with the help of all such things. So with the help of all such things, we are generating power. Sometimes we produce excess amount of power. We need to utilize the same during peak hours. So some of the storage technologies are available in the basis of mechanical, electrical, electrochemical, and electrochemical. In the energy storage, we have a mechanical storage with the help of a pumped storage hydroelectric power station. In the pumped storage hydroelectric power station, the people can transfer the excess amount of water available from the lower end to the top level of your reservoir with the help of the pumping water, with the help of the motor. That water can be utilized during peak hours. They can manage the peak load with the help of the pumped storage plant. In the Tamil Nadu, we have a one plant, very old plant, used to call, I think, Kunda. Another one is a compressed air energy storage is available. Then next one is a flywheels mechanism. And with the help of the electrical storage, we have a supercapacitor, superconducting management, magnetic energy storage, and chemical storages are fuel cells. Fuel cells also one of the very basic or one of the very important storage of electricity. there are a lot of research is going in the fuel cells. Then electrochemical storage, lead acid batteries, sodium-based batteries, lithium-ion batteries, flow batteries, zinc-based batteries, everything available here. So this is the storage technology options. If you want to store energy for a few seconds, minutes or hours, or we can have 1 kilowatt to 10 kilowatt or 10 kilowatt to 100 megawatts or 100 megawatts to 1 gigawatts. The various possible combinations of storage of energy is possible in this case. The smart grid network is transformed power systems network. Here the power is generated. This line shows about the power flow from the conventional system, and this blue line shows the power from the non-conventional energy systems. So everything is transferred, and with the help of the distribution network, easily can transfer the power to the things. Okay, so they are able to manage. We can able to store energy with the help of the energy storage. We can have an electric vehicle also. The electric vehicle also plays a major role that it stores energy during daytime with the help of the solar or other plant. And whenever we need a peak load or we need a power demand, the power can be taken from the amount of energy, electrical energy stored in the electric vehicle. So these are all the things possible. Now we'll see about renewable energy generation. Some of the technical challenges. If you see the challenges, then only we can say that what are all the research issues available in the renewable generation in the smart grid. The renewable energy generation is intermittent. I'm saying that we are having solar plant and windmill and other type of renewable energy generation, but the renewable energy generation is intermittent generation, dependent on weather, season, time of the day, need accurate forecasting and power balancing. You know about windmill, we will get a season only. During that season, we can get power from with the help of the wind. We can generate power with the help of the windmill. And if you consider the solar panel, the solar panel can give full efficiency or complete power from morning 10 o'clock to evening 4 o'clock, even though we'll get a sunlight 6 o'clock. That will give power during 10 o'clock to evening 4 o'clock. Then we'll get a reduced amount of power. If you get some shading effect or something, the power get problem in the generation of solar panel. In the windmill also, if you are connecting, sometimes suddenly the wind fall. What will happen? The windmill come to the off position or a stop position. That time, how to manage? So these are all the problems you are having in the windmill. Then the voltage and frequency control is not that much easy in case of renewable energy. Many of the sources do not have any reactive power generation. Then sudden generation losses can lead to system instability. Generation can stop in case of cloudy days in this from the solar panel, or wind has stopped, the generation has stopped. So due to the system instability, we'll get a sudden generation loss. That time we need to manage. Then power quality issues, harmonic flicker, under voltage write-through capabilities. These are all the other problems you are having. The write-through problem is you are having a windmill stopped at a particular time. With the help of the windmill, you are supplying to the emergency load or some loads. If the windmill gets stopped, immediately the power, the grid try to get supply from some other existing running station. What will happen is if it'll draw over power, the time it will get a problem of managing. We'll get into problem. So complete collapse may occur. So right voltage through problem is another big issues in the windmill. The power management and maximum power point tracking requires proper converters and controls to manage all such problems. Okay. So now we'll say about a curve. This is the load duration curve. We can say that. So this is a time to time. We can see that 0 hours to 0 hours. That is a 24 hours. If you are consider the night 12 o'clock to morning 6 o'clock, the power consumption is very low. And from 6 to 10 o'clock, it will be reasonable amount of power. 10 to around 12 o'clock or 1 o'clock, we will get a maximum amount of power. During lunchtime, we'll get a minimum amount of power. And from 2 o'clock to evening 6 o'clock, we'll get a 4 o'clock, it will be maximum power. 4 to 6, it will be very minimum. From 6 o'clock to night 10 o'clock or 11 o'clock, the power requirement is very maximum. This is the peak load. This one only we need to manage. If you want to switch on the particular power generation for the particular period, it will be very cost effective. So to avoid such things, we are going with the other type of non-conventional energy storage. So this problem can be avoided. If you want to start this, we used to call this is the base load curve. This is a peak load curve. This is a base load. Automatically for all time the machine will run and it will supply power. In the peak load, the power need to generate. We can avoid the peak load problem with the help of this smart meter. Now I told you that the smart grid is going to utilize the smart meter. The smart meter can have the capability to control this amount of peak load. The reason behind it is, do you know about some telecommunication thing? There is a BSNL like thing. They are giving offer in the night hours from night 10 o'clock to morning 6 o'clock. You talk to your friend with the landline, it will be free. During Sunday, if you talk, the landline is free. So reason behind it is they want to minimize the peak load. They want the night hours, the line is free. Anybody can talk. So what will happen is the people, they used to wait for night hours. Nowadays, we are using mobile phone and all free. So we least bother about the timing and all. But previously in the telephone department, they used to charge more. That time they used to charge more. So what will happen is they want to manage all such things. The time for that we are having a provision in the smart meter. The smart meter can have time-based tariff like a BSNL. We can fix the time-based tariff. If you are using the electricity from morning 6 o'clock to 8 o'clock, it will be a 2 rupees per unit. If you are using from 10 o'clock to 12 o'clock or 4 o'clock, the electricity charges will be 4 rupees per unit. If you are using electricity from 6 o'clock evening time to night 11 o'clock, it will be a cost of 10 rupees per unit. So from 11 o'clock to morning 6 o'clock, if you are using electricity, the cost is 1 rupee per unit. So what will happen is the people majority, they don't use the electricity during peak hours. That is, the cost of electricity per unit is 10 rupees from 6 o'clock to night 11 o'clock. Definitely the people will not use the electricity. They will wait till 11 o'clock. After 11 o'clock, they can switch on their washing machine, or nowadays we have an IoT based washing machine. They can fix the washing machine timings 11:05 or 11:10 or 11:30. The time the washing machine started functioning. If you are using the same washing machine, if it is a flat tariff like the current days, so what will happen is if you doesn't bother about all such things, they can started using the electricity during peak hours. If you are having more load, we need to generate more amount of energy. If you are not able to generate more amount of energy to meet out the peak load, that time we will get a problem of managing the total demand. So the problem is we are not able to manage. Now the smart meter solve all such problems. Definitely the people wait for the night 11 o'clock to morning 6 o'clock. That time they can do ironing to press their dresses, or using washing machine, or using pump water from the sump to borewell to the overhead tank. Everything, all such things they can plan for off-peak hours. If you are doing all such things, we are not getting this much of peak load during 6 to 8. So we can manage these things only with the help of the smart meter. Smart meter can have a capability of time-based tariff. So one of the important concept to manage the power or electricity is smart metering. We can avoid a peak load demand. The time we can manage the power generation. That is very important things in the smart grid. So another challenges in the transmission grid is right way, land acquisition, renewable integration, grid management. I'm going fast. I think I crossed the time. Then synchrophaser technology. These are all we can avoid blackouts with the help of this. You know the history of blackouts in the electricity board. In the August 2003 and July 2012, complete blackout happened. So at that time we may not be able to do, just because of the frequency variation and some problem occurs. So sometimes the generation get reduced. So the grid try to get more power from the other generating station. So what will happen is everything getting collapsed. You assume that you are taking 4 persons are taking like a rhythm. 4 corner they are holding the rhythm. if one person is one side, one corner, one person is not holding properly, what will happen is the remaining 4 persons getting more weight, and they may not be able to manage. So what will happen is the complete system is getting collapsed, and so total system will get a problem. Simply like that, the electricity board also, if one side we are not able to support, the remaining side also getting problem. So these are all the things can be avoided with the help of the smart grid. So this is the another synchro-phase technology in all India grid. Then few major challenges in the smart grids are reliable and fast communication, big data, cyber security. I told you that electricity board in the smart meter, each and every 5 minutes or 1 hour or mentioned time that data is transferred to the centralized place. Definitely we have many devices, each and every device should be connected, and each and every device generate data. So huge amount of data is transferred from the individual houses to centralized place. So we need to manage the big data. And the cyber security, already I told you that cyber security is important thing. So we need to, if one person knows about the password easily, they can capture everything. So that should be taken care. Then integration of other devices also important. Then suitable converter topology and controls of renewable energy systems integration is another challenging issues in the smart grid. Optimal setting, sizing, and controls of energy storage system is more important. We need to plan for better energy storage system. Dealing with the intermittent generation, flexible generation, and thermal storage, everything required in case of things. Adaptive protection in active distribution networks, microgrid protection, all required in case of a smart grid. Then regulatory changes is required in smart grid. So these are all the other things. This is then again about another thing. Yes, some questions. Shall I complete and so this is the bulk generation, transmission, distribution, customers. So this is the communication side. We can able to transfer all such things. In the communication side, we have a hand. There is a home area networks. There is a then business or building area networks, industrial area network, and we are having a neighborhood area network and extended area networks and field area networks. Lot of different area networks are available. They are divided in a small houses. We have a small networking. Next level. They can transfer the information to the final level. So this is the another diagram for controlling, monitoring and control of active distribution networks. So easily they can control this device. Easily they can collect all data. This is the distribution management system. This is the relaying tool. This is the another thing. So easily they can able to control all such things. This is the example given for controlling mechanism. So microgrid and for integration of several sources and storage. This is a microgrid. The difference between the microgrid and the smart grid is microgrid is from some area in the university or college. If you are having your own generation with the help of the thermal, with the help of the solar or the windmill, you can manage all such powers. It may also connected with the electricity board. Some problem occurs with the total electricity board, you can isolate yourself and you can utilize the power generated by yourself. If any amount of excess amount of power is required, then only we are going for a electricity board. So microgrid is a small area. We can generate our power. We can use it even for a small village or some places. They can generate their own power and they can utilize it. In the microgrid, they have AC power as well as the DC power. And a few challenges in the microgrids are, this is a voltage stabilization, power management, power quality management, protection, grid integration, stability issues, islanded operations are all such things. These are all the research and development need is design of microgrid architecture, AC versus DC microgrid, converter topology, control architecture, MPPT algorithm is required to get maximum amount of power from the renewable energy resources. Adaptive and fast protection scheme is required. If any problem occurs, that should be protected. Islanding detection and management scheme is required. Smart inverter converter with the networking control feature. So virtual inertia generation, micro EMS is research development required. If you are doing some research, the government is ready to give funding. This is central government, this is a Ministry of Power, MNRE. They have a authority, something like this, and they are reduced to provide funding for you. This is the total status of your renewable energy as well as the total capacity. Renewable energy, there's almost total renewable energy is 78.317 gigawatts. And through other sources, we are having the power and the total installed capacity is 350 gigawatts total India. And in the renewable, we are getting 75 gigawatts power. And this is the total power position in this. This is all the region wise they are having power systems. I think I don't have time, I can move fast. So the smart grid, we are having India Smart Grid Task Force set up in the years 2010. It's an inter-ministerial group to advise Ministry of Smart Grid domain. And the India Smart Grid Forum, they are conducting many conferences and they are conducting many programs. They are monitoring all such things. So it's a public-private partnership initiatives to act as advisory to Ministry of Power regarding smart grid. And the National Smart Grid Mission is available. That's set up in the year 2015. This is a planning for monitoring all such things and responsible for development of smart grid under smart cities mission. Then NSGM project also they are having, and PMU located in power grid for project approval and monitoring, everything done by NSGM. Then expert panel on smart transmission grid is available for the power grid. So some of the challenges in the smart grid is, I'll complete it in another 5 to 10 minutes. Okay. So some of the smart grid is renewable energy integration is the main problem. We are having many solar panel in each and every houses. How to integrate all such things? We have a windmill. How to integrate all such things? This is a major issue. Then the energy storage system. We need to store more amount of energy. If you need to manage some unavoidable situation, we need to store energy. Self-healing. We need to control and we need to heal everything, rectify everything. Then power system reliability is more important. Power quality, privacy, security is more important. The integration, we are having wind forecast and wind generation dispatch. The wind forecast already told you that it is seasonal. At any time, wind can stop. So we need to manage. So intermittent in nature, it is not easy to have accurate prediction of wind, especially on the long term. And weather wind generation dispatch also based on the weather dependent. If the weather is not good, we may not be able to generate wind energy. Then it will be a problem of managing all such things. Then power flow optimization is required. Then power system stability is more important in case of things. Okay. And with the help of the energy storage system, we have a if you are going for a more amount of energy storage, definitely cost will be more, complexity is more, it's a non-flexibility. If you are having storage of energy for a particular purpose, you can utilize for the particular purpose only, not for all purpose. That depends on the capacity and other things. So non-flexibility, it cannot be used for some other purpose. So these are all the problems in this. And another one is grid automation and grid configuration. Reconfiguration is more important in case of things. And the quality, regarding the power quality, we need to maintain the disturbance identification and harmonic suppression. Everything should be taken care. The researchers can concentrate on these areas. And another one is a consumer motivation. We should teach the consumers how we are save the electricity, how to utilize the smart grid. Everything should be give information to the consumer. Then only they can avoid wasting of power energy. Then another one is a privacy and security. Privacy and security is more important. If you are having some problem like this, definitely we may not be able to continue the communication properly. If the communication is not proper, definitely it will get a problem. The security, I want to give one information. Security is more important. Even if every one of us, we are having your own user ID and password for your email. So the email password, you won't give it to anybody. Generally, the people are, the security people used to say that the user ID is open to all. The user have their own password. The password is a more secured one. The password should not be shared with anybody. The password is like a toothbrush. If you have a toothbrush, you won't share your toothbrush with anybody, or you want to periodically you want to change the toothbrush for 3 months or 6 months, you want to change the toothbrush. Simply like that, your security password also you should change periodically, as well as you should not give share your password with anybody like a toothbrush. So security is more important in case of a power grid. Okay, so these are all the challenges in smart grid. This is the smart grid funding in India. So if you are, the researchers can concentrate and will get a power from the fund from the Ministry of Power through the things they have got some of the funding, and these are all the power grid system development fund, professor. These are all the fund and already running projects are available. You can utilize and you can get idea from this and you can get funding. The Ministry of Power has given the initiated the pilot project. The pilot projects are available here. These are all the various pilot projects already running. So they are concentrating on AMI, power quality management, outage management system, peak load management, distribution generation, smart home solution, and smart analytics. So these are all the various research issues we can concentrate. In the smart, one of the important concept in the smart grid is don't feel that electrical engineers, I'm an electrical engineer, I know about a machine, I know about a power system, I know about electronics. So why should I want to know about the communication or computer? Definitely nowadays, computer communication programming is more important for each and every one. If you are thorough with all such electricity, now electricity alone will do nothing. So we are connecting communication with the computer. So the communication computer connected with our power grid. So then only we are able to do all such things. As electrical engineers, I don't know, the crowd may, the people, participants may be from electrical or computer or other branches. So this is the inter-platform work. So you can do more inter-platform based research and more work in the smart grid. So please concentrate on or have a group with EEE electronics, computer science people can join together and work for the smart grid. So already I told you that smart grid have a two-way flow of electricity as well as two-way flow of communication. It aims at large development of distributed energy resources, microgrid, power electronic interfaces. Renewable integration will possess power management and stability challenges, which needs proper control to be implemented. Then we need to modular integration approach, open protocol and common informations need to be adopted. It will also require big data analytics, cyber security measures to be adopted at various levels. India has a separate renewable energy mechanisms, green corridor, other things are available. So smart and secure distribution networks development will require integrating microgrids with renewable and storage. So these are all the references I have taken, and thank you. If you have any queries, if you ask, and I'll give the things to organizers. Thank you. If you have any queries, somebody's raised your hand, and I don't know who's it. Any queries?
Thank you, sir. Thank you for the wonderful session. Sir, may I request, with your permission, shall I ask participants to raise their queries, sir?
Yes, sir. Please, sir.
I request all the participants, if you have any queries, you can post in the chat box. Participants are requested to post their queries in the chat box.
I'm not able to see the.
Sir, one of the participant mentioned their query. What about cost comparison between conventional and smart grids?
Actually, we know that we used to do that power analysis, right? Existing one, we are replacing with a new one. Definitely, we'll get a more energy savings and we'll get a more losses maybe get minimized. So definitely, initial cost will be more, but after sometimes the running cost will be very minimum, and we can avoid wastages. One example is previously we used to have a tube light with help of the choke. Nowadays, we have replaced every tube light with the help of the LED bulb. So what is happening? So the power consumption is very minimum with the LED. Previously, we are used to 40 watts bulb with the minimum brightness and illumination level. But nowadays, we are getting a tube light with the 20 watts bulb with more brightness than the previous one. Simply like that, the initial cost will be more. We want to replace some of the systems. For that, we need to spend for it. Then we will get a more beneficial, reliable, and efficient economical. So we need to change it. Cost-wise, it will be reasonable to change it. Even in the energy meter, also cost of 20,000 rupees yearly. So that's why the electricity board, they are not interested to replace all such meters with the individual houses. The individual won't spend that much of amount. So definitely we need to have face all such things. Okay, cost will be more only. Yes, please.
Thank you, sir. And the next question is, what are the challenges to reduce costs in power electronics?
Power electronics, with the help of the power electronics, we can reduce it. I am not clearly related with our topic. With the help of the power electronics, we can do more things in the smart grid. So definitely with the help of the power electronics, we can reduce the cost only. Your question is, with the help of the power electronics, what is meant? Please repeat.
What type of, sorry, sir. What are the challenges to reduce the costs in power electronics?
If you are moving with the power electronics, definitely the cost will get reduced, ma'am. Not, I think, directly with our topic. Please.
Okay, sir. One more question. What type of sensors used for self-healing?
Normal sensors, ma'am. All such, even in the fan, I told you that in the fan, we are having a small sensor, temperature sensor, that gives the temperature as well as the noise information to the smart grid or some display system available in your houses. So the sensors can give information to the central board for such a problems. Each and every devices can have its own type of sensor. Sometimes it required thermal sensor, sometimes it required sound sensor, sometimes it required other types of sensors. So it depends on the particular equipment or domestic equipment or individual electrical equipment, the thermal sensors is required. We have many sensors. Please.
Has IoT been used for communication in smart grid?
Yeah, IoT is a major role plays in the smart grid. Each and every devices we can. I already told you that in the mobile phone we are having app. If you are moving towards your house, nearly 1 kilometer to your house, automatically the mobile detects your area and it gives information to your houses, and the light is getting on or the AC is getting switched on. Something you get it is doing. So IoT is closely related to the smart grid.
And one more question from Satya Kannan. What are the main challenges in modern power distribution networks?
Main challenges is in the communication side. If you take the security is the main challenge. More power electronic devices should be added with the existing things. We need to spend some amount for that, and we need to integrate renewable energy sources. The integration of renewable energy sources is a major challenges. I given challenges in the last few slides about what are the challenges we are having in the smart grid.
Okay, sir. Question from MV Rambabu. Sir, can you share any analysis about communication in smart grid?
Yeah, I'm having. If you want to contact me, I'll share the things. Okay.
Okay, sir.
We are having.
Question from Divya Chauhan. Better topic for research: AC or DC, micro or smart grid?
Microgrid is a part of the smart grid. We are connecting many microgrids as a smart grid. We are whenever we want to isolate from the main grid, we can isolate and we can act as a microgrid. Nowadays, the DC is the very best one, madam. Only problem the DC is we are not able to control like AC. In the AC, we have a control mechanism, but in the DC, we don't have any proper control mechanism. So definitely DC, you can concentrate. It will be a very big. Nowadays, the DC is one thing I want to say about a DC is we are producing electrical energy from the solar panel DC. Whenever we are using DC directly in our houses. Even nowadays, we are having a DC tube light, a DC fan, DC refrigerator, everything we are having a DC. If you are going with a DC, the cost will be very minimum. If you are converting the DC into AC, then we are using it step by step, we are getting losses. So cost will be more. So if you concentrate on DC, it will be more advisable for the research. DC, microgrid, you start and then you can move with the smart grid.
Okay, sir. One more question from Dr. G. Kannayaram. Difference between nano grid and smart grid.
Nano grid is now a small area in a small in a rural areas. For example, in a remote place, for example, 10 houses are available. The 10 houses, they can have own solar panel. They can generate their own power and they can utilize it. It's a small area without any electricity board supply. They are able to manage. It's a nano grid. And a smart grid is for a different power generating station with the help of the hydel, thermal, windmill. We may be able to manage, and we are going with a huge amount of things. It's a nano grid is a small one for a small area and a small amount of electricity.
What is the use of PMUs?
Phasor measurement unit is one of the main function in the smart grid. They can able to control the unwanted disturbances, and you may able to measure the power quality with the help of the PMU. PMU is a very another topic. If you want to take that will take another more time. PMU is plays a major role in the smart grid.
Is MPPT is challenging for us from converters side or load management side or solar cells operation side?
MPPT, we are tracking maximum power from the resources. For that, we are using electronic devices. Definitely in the converter side, it plays a major role.
Okay, sir. Please mention any area need to be more concentrated in photovoltaic generation at current technology scenario.
In the photovoltaic, definitely we need to concentrate on which type of photovoltaic cell give the maximum amount of electrical energy, as well as due to shading effect and other things should be concentrated. Even nowadays we are having window based solar panel also. Something like that we can concentrate on the solar panel.
Okay, sir. Is it possible to prevent the cyber attack completely?
No, definitely it is not possible. Even in any of the industries, even in the government, they may not be able to control. Like in the houses, we have any type of prevention mechanism. We can have our own CCTV camera, alarming system. Simply the thief can manage everything and they can enter into the houses. They can enter into the jewelry shop and other places. Simply like that, anybody can enter into the things like cyber security. It is open. It is transferring information, data in the wireless mode, and they can easily capture. But the thing is, we are having some encryption mechanism, decryption mechanism, security. Everything is possible. Anyhow, it is not completely. We cannot control the cyber security.
Okay, sir. Last question. 3 or 4 participants are asking about the difference between smart grid and microgrid.
I already told you that the microgrid is for a small area, for a particular places or college. In your college premises, you are developing your own power with the help of the wind or solar energy that can be utilized for your own college. That is microgrid. If you are joining your grid with your central grid, it will comes under the smart grid. Smart grid can have many systems like a power grid, over grid. That is a very big one. Microgrid is only small area we can have. We can generate on our own. We can utilize on our own in the microgrid.
Which MPPT technique is better to carry on research work at present?
We have many MPPT techniques are available, ma'am. Depends on the application, which part you are going to utilize. That only says about. Generally, we cannot say that which MPPT is suitable for research area. many MPPTs are available for particular research. Particular MPPT is possible. You can refer many of the papers or contact me, and I'll give the information.
Okay, sir. Some of the participants are asking about your contact details, like your mail ID or something.
Mail ID, shall I type it or how can I show here?
Yes, sir. At the end of the slide, you have mentioned, I think, sir. So just you slide that one.
Or else you can type in the chat box. Sir.
Chat box, sir. It's
That would be
better.
easier.
Chat box. Okay. Okay. Now I'm getting. Able to see the thing?
Yes, sir. Dr. Dot is there, sir.
No. Dr. BASKRAN at gct.ac.in.
Yes. Sir, I have mentioned in chat box. You just please confirm that one, sir.
I'm not able to see the chat box. Myself.
Okay. Correct.
So I'm not able to see.
Okay, sir. Okay.
So Dr. BASKRAN at gct.ac.in.
Okay, sir. Shall we close the session, sir?
Yes, madam. If you have any
Thank
query.
you, sir. Yes, sir. Myself, colleague. Thank you, sir. Your presentation on research challenges in smart grid epitomized everything related with the advanced technologies and the challenges involved in the smart grids requirements in present and future days. It was beyond excellent. We came across some new terms like prosumers and key concepts of cybersecurity, especially the toothbrush example. Thank you once again, sir, for devoting your time and energy to enrich our knowledge towards the smart grid technology and challenges. Thank you very much, sir.
Thank you, madam. Thank you for the opportunity to your college and management principal, HOD, Mrs. Saravanan, and yourself. Very good methodical coordination you have done.
Thank you, sir. Thank you so much.
Thank you. Thank you, all participants.
Shilakma?
Sir.
Shall I stop the recording?
Yes, sir. Yes, sir. Yes.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.
Yes, sir. Thank you.
Sir, I'm closing the session.
Yes, sir. I'm also closing. Thank you very much for the opportunity.
Thank you, sir.
Thank you, sir. Thank you, sir.